to tonight, our first in the 10-minute tech series. You can find out more information about Sheep Connect at our website, sheepconnectsa.com.au, or you can follow us on Twitter at sheepconnectsa. Such a project as Sheep Connect is not possible without our funding partners, and we thank them: AWI, Primary Industries and Region South Australia, the Sheep Industry Fund, the South Australian Arid Lands and South Australian Murray-Darling Basin NRM boards, and the Australian Government. Just like you take a moment to read the screen in front of you from the Government of South Australia. It's my pleasure tonight to introduce the first of the speakers, Cameron Young, who's the Managing Director from FarmBot.
Thank you very much, Jodie, and thank you, Pet, for a great forum. And welcome, everybody. Thank you for your time tonight on what is Game 1 State of Origin, which may not mean much to you South Australians. So, as Jodie suggested, I'm the Managing Director of FarmBot. The FarmBot, we are what we call an Internet of Things business. So we are making connected devices, and we happen to specialise in the agricultural industry, and with a particular focus on water management, measurement and control. What we deliver is a fairly cost-effective, turnkey solution with a particular emphasis on the client support. So that is, we manufacture the hardware that monitors water in tanks, dams, channels, soon to be water flow, and other applications on farm. Now, setting the scene for most of you, current predicament you face in managing your water resources on farm is such that it's your water resources are spread across a large geographical area. To inspect those water resources on a daily, 3 or 4 times a week is very costly. It's time consuming. Unfortunately, once your bore runners or yourselves have inspected water, you have no idea about the issues the minute you leave those water resources. You have limited intel or intelligence on the consumption trends that are happening out there, and driving long distances over dusty roads frequently increases the potential OH&S issues. And lastly, but not least, is unfortunately there is no ability for you to take your eye off the ball. So telemetry and FarmBot, what we do provide is the ability to manage your remote water assets from your home or from anywhere you have a connected device. That is, you can put a monitor. You can put a monitor on a body of water. It will transmit the data via satellite for the vast majority of you, or those of you who've got within a mobile coverage over a 3G or 4G network, to our cloud servers, and deliver that data into what we call a user experience, and that is the web application. So basically what we do is we provide, we take the hassle of your manual water inspections, or at least vastly reduce the need to continually manually inspect your water assets without make it a much more targeted approach. So these are some of the features and benefits of the FarmBot monitoring solutions, or telemetry in general. It's about giving near real-time information. That is, when you have problems in the field, when your tank is dry, when a pipe is broken and water is draining out of your tank, you are able to be alerted via an SMS, or if you happen to be on the web application at the time, you are alerted in real time. The graphical, the data that is displayed is detailed and enables you to see a great deal about the consumption trends of your livestock. So the warnings are timely. You're better able to understand your usage, the times, and plan your water runs, your water inspections with a great deal of accuracy. Installation, is meant to be easy. We suggest installing a water monitor should be easy. It should be done in 5 to 10 minutes. Gone are the days when you need to calibrate your monitors. Gone are the days when you need a technician. The expense is taken right out of the logistics channel, and anyone on the farm should be able to install a water monitor. Certainly with FarmBot monitors, that's the way we build them. And the ability, as I said, to access your data anywhere, anytime, on any connected device. And lastly, again, certainly not least, is it doesn't matter where you're situated, you have access to the data through a direct link to a satellite. We at FarmBot use one of the larger satellite players, and that gives us the access to have real-time or very near real-time information. On the screen in front of you at the moment is some of the solutions that we provide. Tank monitoring, you can see on the left-hand side there, very small unit. It's solar panel with solar panels as a battery inside. All you need to do is put the 4 screws into the tank, face it due north, turn it on, and walk away. There's a pressure probe that sits inside the tank. It doesn't need to be calibrated, and it takes a continuous reading of the water levels in your tank. Dam monitoring, turkey's nest, very similar. The second screen on the left, channel monitoring for those that have the need to measure a rapidly rising or falling channel. We use both transducers and what's known as an ultrasonic device, and that's where it's using sonar, so a sound waves that bounce off the water to take the levels. And there is an automatic rain gauge that can be attached to the monitor on the side. No need to empty it or inspect it. It empties automatically, and you can, along with your water levels, find out any rainfall over a day or a week, a month or a year. Part of FarmBot's offering is around the service. We understand, particularly in agriculture, that it's often not the product that you're selling, it's the service, it's the backup support. And for our clientele who are particularly keen on knowing what happens when technology fails, there still is a fair reluctance on behalf of many farmers to engage in technology, simply because when it fails, they don't know who to call, what to do, or the cost or expense that is involved in the fix. So we structure the business where selling the product, the hardware, is only the beginning, and it's the support after that that is the most important aspect of what we offer. It's called a SaaS platform. You may have heard that. It stands for Software as a Service. And we've had a particular focus on providing what we think is a very high level of service. When there's an issue, our algorithms and software within our system pick up the issue. We know when a monitor is not transmitting data, and we alert the farmer to the problem, and we rectify the problem. So we either post a new probe, we determine whether it might be the satellite might be down or the network might be down, whether there is an issue with a tank. Whatever the issue is, there's a fix. So moving to what we call the UI, or the user interface, and that's the web app that you engage with on your phone or the PC. This is set up for a South Australian client, actually Jump Up Pastoral, I think it is, and they have a number of monitors over 9 different properties. And the first screen when they log in is the 8 or 9 monitors you see. Basic information on the screen on each of their tanks, which has the percentage full, the direction of the water, whether it's draining or filling or flat, the value of that in centimetres of the tank, and whether or not there has been an SMS alert go out to the farmer. Drilling down into that user experience, on each of the tanks, you're able to get a very detailed graphical representation of the water levels. From this particular screen, you can add multiple alerts. So on a particular tank, if you were worried that when the water level dropped below a metre or 80 centimetres, it might be notifying 2 people with a secondary lower limit that could notify 5 people. From that screen, you can action it and acknowledge it depending on who has seen it and depending on who is doing something about that. Also, in the top left-hand corner, you've got a little map. The client is able to click on that map and find out every monitor that is located on their property and all the pins. You'll be able to see the water levels. Quick synopsis of where our monitors are. It's a little bit old, but we're represented in every state and territory, quite a few in South Australia, and growing pretty rapidly. This is what we're most proud of, and that's the feedback we get from our clients, the farmers, and we regularly assess ourselves by discussing the improvements we can make, and also certainly the things that we're doing well. You won't have time to read this testimonial, but it will, as I understand, the presentation we made available post this live webinar. We also offer our new clients an opportunity to trial and monitor our monitors for 4 weeks. If they don't perform exactly to spec, there is the ability for that client to put the monitor back in the box and send it back to us. Thankfully, that doesn't happen very often. In fact, I don't think it has happened once. Our pricing schedule. Here, what you've got is 2 components to the pricing schedule. One is the cost of the monitors, that's the hardware. And secondly, as I mentioned to you, there is a service fee which covers the data, the SMS alerts, the software and the warranties. This is some of the additional sensors that we have in development at the moment. All of these sensors will be finished by the end of the year. So at the moment we offer a satellite or a 3G, 4G enabled monitor with an automatic rain gauge. We are currently in phase 2 of the phase 3 development program, developing flow monitoring capability, pump control, water quality, and a wireless electric fence monitoring. And we have started work on developing a camera functionality, which we expect to finish over the course of this year or early next year. I think that's my time. Thank you very much for listening. I hope you have seen something of interest, and I would welcome any questions.
Oh, that's great, Cameron. No, that's amazing. Very interesting. And we have got a few questions coming in. One of them being, can it automatically shut off the flow if you have water problems, like flooding or breaking?
Sure. Great question. What we will offer is with the flow monitors. There's a lot of hardware applications available in the marketplace. We're not developing the hardware that sits inside the pipe. What we will be doing is taking a pulse reading from that pipe into the monitor and then transmitting the data from the monitor into the user experience screen. So it's an interesting question, and yeah, that could be on version 2.0. I like it. The flow monitors is when you've got a level sensor and a flow monitor, it does give you a much deeper analysis of the levels and the water application. So yeah, I imagine it would be, because the pump control is about a bidirectional control, and that's sending an instruction to a pump, possibly that has been triggered via a level in a tank being breached. And so you can send instructions up and down. The ability to shut off a pipe could be one of those instructions.
Okay, good. Thank you, Cameron. And what water qualities are you going to test is another one we've got coming in.
Yeah, great question. In the initial phase, it would be around turbidity and alkaline. There is a myriad of other applications, other chemicals we could test. And it really depends on the area. We know that we had some interest in southeast Queensland from a mine that was fracking. They leaked benzene into the water table, and all the farmers in the region were particularly concerned around the benzene. So, yeah, it will be specific to an area, and would be guided by the demand.
Okay, thank you, Cameron. And with the alarm monitors in troughs, etc., can you pre-program them to go off at a certain level, and can it be more than just one level, if that kind of makes sense?
Yes, it does. The answer is yes. You can set it off. You can have 3 different levels, and in fact, each level that's breached can escalate the number of people that receive the alarm, or what we call the alert. So level 1 might go to 2 people, level 2 might go to 4, and level 3 might be code red and go to 8.
Brilliant. Okay. And so I suppose it's a very personal setup, but in smaller farming areas that aren't perhaps as pastoral as the one like Jumbuck Pastoral, do you have more sort of trough sensors than tank sensors in a smaller farming enterprise, or is it purely a personal preference?
It's a personal preference. We've, by number of clients, the majority of our clients are smaller farmers, and I'd say smaller, sort of 5,000 acres or less, or even a lot of them are absentee farmers, so they might live in the city or a city and travel there on the weekend, and they might just have a one water resource. So yes, under those scenarios, it's perfect for one. It might be one bore monitor, and generally they'll be operating over a 3G network rather than the satellite.
And I suppose that leads into the next one, Cameron. Are there any limitations with notifications, whether it's distance, whether you're in an area that is surrounded by a lot of hills and trees and interference, that type of thing?
No limitation. Every bit of land on Earth can receive a satellite signal, and if you use one of the larger satellite players, you'll always get a signal. So the smaller satellite players that might only have half a dozen satellites, you've got to wait till that satellite is overhead before you can transmit data. The larger ones might have 20, 30, 40 satellites in the sky, and at some stage there's always a satellite overhead. We use one of those larger ones, and so the data is always transmissible.
Right, okay, thank you, Cameron. And there's another one here that says, in regards to the technology, is it required to be upgraded fairly frequently, or is there a lot of maintenance involved?
There's no maintenance. When we've had issues in the past, and we have had issues with our hardware, we have it's quite a compact unit. The issues we've had have in the past have been more around the probes. When I say issues, we're still talking 5%. We picked those issues up. We were able to send a probe in the post to be received 2 or 3 days later. They're switched out and the issue's fixed. On the occasions that we've had an issue with the monitor, the model is simply post a new monitor to the farmer, and they'll swap them over. Our units have been struck by lightning, the birds have eaten them, they've been dropped, they've fallen off the back of the ute. They've been underwater, in fact, end of last year. They've been in cyclones in the northwest. So yeah, all sorts. They've got to be robust. There is issues, and it's not so much the issues, but it's the way in which you deal with them and how quickly you can repair them. So we focus on fixing the issue and asking the questions later and dealing with our suppliers, as opposed to asking the questions, getting the box sent back to a repair centre, which can take anywhere to 4 or 6 weeks, which is no good for the farmer.
No, that's right. And so we might just leave it there for the minute. Thanks, Cameron. It's a fascinating subject, and I'm sure there'll be more questions come in at the end. And I will pass to Jodie, who can then introduce our next speaker.
So it's my pleasure to introduce Emma Shattuck's talk, and Emma is the livestock production advisor with elders at Burra.
And thank you to PIRSA, who've asked me to speak today a little bit about water for livestock. So a few of the things I wanted to touch on are, firstly, how much water do different classes of stock need, and then we'll have a look at quality in a little bit more depth, and what are some of the factors that can influence animals' production. Finally, I'll have a little chat about infrastructure and some of the physical requirements when it comes to setting up water sources. Okay, so the really big take-home message for today is that if you approach nothing else on your property, approach water. So a lot of people get hung up on minerals, and minerals are no good if you don't have the energy and the protein in the diet, and the energy and protein are no good if the water's not there. So you could have the best diet in the world, but if the water's not right, everything still falls apart. So water really is the very first consideration when it comes to stock nutrition. So I've got a bit of a table here on some of the daily requirements for stock. These requirements do vary, as you can see, depending on the class of stock. So lactating animals, because they're producing milk, will need more water in a day than a dry animal equivalent. Young stock will need a bit less because they're smaller animals. But you can also see on here that the feed type can also change the water requirements. So the example on here is if animals are on a salty feed, so something like saltbush, their water requirements are going to be higher than animals grazing fresher grass-based pastures. The same goes if people are supplementing with salt-based supplements, so something like salt blocks. To some extent, these can increase water intake, but if the water quality itself is marginal, which we'll have a talk about in a minute, then that appetite can decrease, so production's affected. A few of the other factors that do affect water requirements and water intakes is the water quality itself, which we'll have a look in a minute how that works, but also the weather as well. So in hot weather, animals need to drink more than in cool weather, and quite often in winter they'll be getting a lot more of their water requirements from the actual feed itself as well. So for example, sheep can drink up to 40% more in summer than they do in winter. And water consumption is also higher in a drought. So animals on a higher fibre diet will need more water, and then they also will get a lower salt tolerance as they get weaker from the drought conditions. Okay, we'll touch now on quality. So I've listed here a few of the key points to think about, and then there's a few others we'll explore in detail in a minute. So firstly, we want water that's palatable, which is a pretty generic term, but it generally describes all of the quality factors we're going to discuss in the next 5 minutes. So firstly, we'd like cool water. So where you can, keep your pipes buried underground so they don't, especially black pipes, so they don't sit on top of the ground and heat up. Have your water sources shaded. Particularly in summer, and animals that have higher water requirements, they really do look for cool water. So if the water's warm, they'll drink less, which means they eat less, so their productivity drops. It's also really important to have clean water, and again, as those requirements are higher, it's more important to clean that water regularly. And of course, we want water that's odourless as well. So if we have water with a strong particular odour to it, that can deter stock from drinking it. So again, they'll drink less. The ideal pH range for water is 6.5 to 8.5. So underneath that range, so if the water's too acidic, we can end up with trouble with acidosis and reduced feed intake. If it's too alkaline, so if the pH is too high, we can get digestive upsets and diarrhea, and again, reduced feed intake, water intake and production. The last one on this list here is total dissolved solids. I've put this one on here because this is a measure of the dissolved salt ions and the dissolved organic acids in a water sample. So it's highly correlated to salinity, which you'll see in a minute is that group of dissolved salt ions. So looking at salinity, I won't go into all the numbers on this table, but I just wanted to point out a few trends. So this shows the different classes of stock and how tolerant they are to salty water. So you can see here that sheep are the most tolerant group of livestock for saline water. However, when you're talking about young stock, so weaners, pregnant stock, lactating stock, their salt tolerance is significantly lower than a dry adult sheep. So that's something to keep in mind as well. And if you've got a block with variable water quality, is putting the sheep who are more sensitive to that salt level on the better water. British sheep breeds also can drink 20% more water than merinos in hot weather. So that's going to impact how well they can tolerate salinity. And when it comes to cattle, the Bos Indicus breeds, so things like Brahmins and their crosses, they'll drink less in hot weather than the British breeds. So again, something to keep in mind when you're talking water requirements and the salinity levels that they can tolerate. So I mentioned before that salinity is a measure of all those salt ions. So this isn't just sodium chloride, it's also measures of calcium salts, magnesium sulfide, carbonate salts. And it usually is the most important limiting quality factor when we're talking about water for livestock. So I think we've touched on this before, but the symptoms you can see with animals on high saline water is, to start with, a reduced appetite, often goes hand in hand with reduced desire to drink that water. You can see scouring, and we also end up with a whole heap of microbes that get lost out of the rumen. And the reason for this is the salty water changes the osmotic pressure in the rumen, which means we've got a higher flow rate of water coming through and it flushes a lot of those microbes out. So that then causes a drop in the feed conversion ratio. So we've got less productive stock. Now, generally speaking, surface water has less saline than underground water, but surface water can vary quite considerably. So it'll depend on levels of evaporation. So in the height of summer, the water can be more saline than in winter when it's getting replenished rather than evaporating. Also, when you do get a rain for things like creeks and riverbeds, if there's any dissolved salts on the banks and the rain comes and dissolves them and washes them in, you can have a temporary increase in salinity as well. And again, the tolerance to saline water for animals will vary depending on the type of feed they're on. So they're less tolerant on dry feed than they are on green feed, and less tolerant on salty feeds such as saltbush as well. Okay, some of the other quality factors we're looking at is particularly contaminants. So any debris, which might be stubble or plant material washed into dams and waterways, or dead animals. It's important to get these out as soon as you can, because they can cause not only odours, but also increase the risk of salmonella in livestock as well. All the heavy metals, we want to try and stay away from them. So they're things like your arsenic, lead, mercury, zinc, fluorides, and also your pesticides. So any cropping chemicals, which is important where you've got dams in cropping areas and there's a lot of runoff. Magnesium, calcium and sulfate levels are also quite important, and especially any of your nitrogen fertilisers. So it's really important to never reuse any chemical containers for stock water. I've seen a good example of this where I went out to a place and someone had reused, like drained a nitrogen fertiliser, liquid nitrogen fertiliser tank, filled it up with water for the feedlot, and those animals consequently got nitrate poisoning, which in a nutshell means they suffocated and died. So it can cause quite significant losses with some of those contaminants in there. The other one on the list is algae. So not all algae is toxic to livestock. It can deter them to drink if you've got troughs that are quite blocked up, and it can cause blockages in your pipes and bits and pieces like that. But the main point with algae is if you've got blue-green algae, which is toxic to livestock. And even after you've treated a waterway, say a dam or a trough, that algae can release toxins as it dies, so the water's still unsafe for at least another 2 or 3 weeks after that. All right, we've touched a little bit now on infrastructure. So the first one I've got on there is flow rate. Flow rate is really important, and especially for large mobs of sheep. So when we're talking mobs of 600 or more sheep that all are drinking on one trough, the tail may not be able to drink enough for what they need in a day by the time the mob started to move away from the trough again. So that can cause significant problems, especially in summer. If your flow rate is suitable, so if you've got nice high pressure, then that trough is consistently filling up and the stock don't have to wait around for that trough to refill before they can have a drink. Troughs versus dams, this is always an interesting debate. A lot of people have noticed that young stock tend to do better on dams. This is quite often to be thought due to simply their ability to find water or recognise, what a trough or a dam is. But it can also be due to that flow rate as well. So when you're talking a dam, you've got a large body of water, and you don't have to wait for it to fill up before the end of that mob can come in and get a drink. So anyway, on that note, it's always really important with any young stock in a new paddock to push them onto the water source so they know where to go. And trough space, if you are relying on troughs, can be very important. So with sheep, rough rule of thumb is to work on 30 centimetres plus 1.5 centimetres per head if they've got access to one side. And for cattle, it's 30 centimetres for 10 head. Watering points is the other one that quite often can get looked over. So especially when their water requirements are high, livestock tend not to graze too far from the watering point. So for example, if you've got weaners on a loop and stubble in summer, 500 metres is about as far as they'll go effectively so they can still come back in for water. What this means is, depending on the shape of your paddock, the position of watering points such as troughs is really important. So if you have a long, narrow paddock, for example, and the trough in one end, the sheep are really going to only effectively graze that half closest to the trough. Whereas if your paddock's more of a square shape and the trough's more in the middle, then they're going to effectively graze most of that paddock. So that does make a big difference. Also the number of watering points. So animals on dry feed, which have the higher water requirements, and in a paddock of say 100 hectares or bigger, you really need at least 2 troughs or a portable trough that you can move around to get that effective grazing. For pastoral areas, the grazing radius tends to be a fair bit larger, so 2.5 k's for sheep and 5 k's for cattle. So just before we finish up, I do want to have a quick chat on strategies if you do have poorer quality water. So the first one, which we discussed a little earlier, was stock allocation. So putting your more susceptible livestock, lactating ewes, lambs, pregnant ewes or cattle, onto the better quality water, and then running your dry stock on the poorer quality water. That can be one strategy that can help where you've got variable water sources. Also the feed type as well. So if you know your water does have some salinity issues and you've got the ability to modify your pasture, try to get something that isn't too high in salt and pick supplements that aren't that high in salt as well, so they complement each other. And also I've seen some properties where they'll actually mix different sources of water and shandy them together either through a pipe or into a tank to try and dilute that, mainly salinity levels, but also dilute a few other minerals as well with the stock.
Thanks, that was the presentation from Emma. It's now my pleasure to introduce Peter Whittlesey from Mount Eva Station. And Peter's going to talk about his desalination plant. So I'll hand over to Peter.
Yeah, hello to everybody. I'll just give you a little bit of background stuff first in regards to Mount Eva Station. Is just for ease of where it is, I suppose, is the middle of South Australia, or where the geographical centre of South Australia is on our place. And it was good to listen to some of Emma's stuff there too. Our water levels sit in that high, or in the middle to the high end of all of that. So our best ones, I'd probably talk in parts per million rather than ECUs, I think, or I'm not exactly sure the technology or the term she was quoting there, but where 3,500 parts per million is our best, which is here at the house, and then we go up to 11 or 12,000 parts per million, which is pretty much unusable water for the stock side of it. So yeah, that gives you a bit of background of where exactly we are. It covers a large pastoral area and it's a bit of size to the place. Now the desal setup, we're 2 years into this process, so I'll give it a crack at trying to explain and talk to the picture, which hopefully you've all got up on your screen there in a minute. There's a little company called Pure Drop Desal, which operates out of Victoria. It just happened that my father, who is, if you can believe this, 77 and read the Weekly Times, an article in regards to this setup had been a cheap and easy desal thing, which is usually the power and the cost of desal is the big negative thing, whereas this setup is relatively cheap compared to a lot of desal operations. Anyhow, I had a phone number in this article in the Weekly Times, which I rang to try and get our water back to, I guess, well, we've actually got it back to drinkable water now. I'm drinking it now, so it's all, you know, it has done the job, but it's taken me 2 years to get to this point. So the guts that we started off with trying to get a grant to help us get over the process, because the water, we were hoping to lower some of our salt levels in some of our stock around the house, holding areas around the house here, especially when we'll move in through shearing and we'll have large mobs up to sort of 7,000 to 10,000 sheep come in on the main homestead area and the holding paddocks here, and they all drink a lot of water in a hurry, and they're under stress having walked probably the furthest outer parts of the station are sort of 60 k's out. So some of those animals have walked the 60 k's over probably a week or more to get them in close enough here. So they're under a relative amount of stress already by the time they get here. Then we add that with salty water, and it puts the whole job under a bit more stress. So the guts of the plan was to try and get that water, lessen the salt level as much as we possibly could. So we started off applying for grants to be able to do that. We were unsuccessful in the couple of grants we went for, and then we've decided to go ourselves with the guts of it. So I won't try to bore you. I'm a bit Scroogey probably in some of the money fronts at times. So everything's got to have, I'm looking for a result, and then we've got to try and do it with the best monetary part of it, or the payback period, as quick as we possibly can, or as good as we can. But at the end of the day, without compromising the result of what I want to get to. So the aim was pretty clear, to try and lower the salinity here at the house. So that's the guts of where we started. What you see in the picture there now, I'll start talking to that, was all freighted to me. The guts of what you're looking at there is about $8,500 worth. And I'll go through some issues I've had with all. I've had to swap a few things around in the 2 year period, but I'm comfortable enough of where that sits now. So it's fed by two sources of water. There's a bore here that the house, which is lacks any quantity of water, but the quality for this area is quite good at 3,500 parts. And then there's another bore that we feed further away into the same system, which is at about 6,500 parts of salt. We've had to supply the water tests to Pure Drop in regards to setting the machine up. So they've had a full water test of the quality there, and then the machine was sort of set up to suit both amounts of water. When we can, we try to operate on the lesser amount, the better quality, so it turns out more supply for us. But with both of those amounts, we're turning that water into drinkable water here at the house. The starting point is at that bore at the house. It pumps into a settling tank, or a tank that settles. We've had some iron issues, which I've worked out over time, which I might touch on a bit further down the track here. But so that the process there is it's pumped out of through a submersible pump to the surface into the settling tank, and then we suck from the top of that tank with a little pressure pump. That pressure pump feeds, which is about 300 metres away from the picture I'm showing you here. That feeds into this system. It's a little 0.5 kilowatt. Actually, what I should have also pointed out is we're operating purely on solar and generator power here. We have got no mains power, so it's all solar and generator and a big set of batteries at the homestead here. So the motors are relatively important to my setup, so we're not using too much power. So it's a 0.5 kilowatt motor that pushes up to the system here now. And when that pushes up to 40 to 50 psi, and if you see on the right hand side where the electric cord goes in, there's a little pressure box there. As soon as that pressure gets to about 25 psi, the whole system kicks in. So I've just got a timer down there, so if I'm only pumping 4 hours, the power will turn the pump on. The pump pressurises the system. As soon as the system's pressurised, it clicks in like that little switch, and then goes from there. It runs into the blue filter, which is a 1 micron filter, which we do go through a few of them. They're about $40 a pop, and they last about a month or 6 weeks, the way I've been going. And that just keeps any iron that comes through the system or any other little bits of grit. The house bore also pumps a little bit of sand. That's why that settling tank's relatively important. And then you'll see there's another little grey box alongside of the blue filter, which pumps out of the red drum that I've got sitting there, which is an anti-scale thing. It just puts a little dash of a mil in every sort of minute, more or less, of the anti-scale procedure. And then it pushes into the big black pump there that pressurises the 4 cylinders you're looking at higher up, which are all, the membranes are inside that. That pressure will go up to 200 psi or more, and pressurises the whole show. And good water comes out the bottom, and the salty stuff or the brine goes out the top. It produces 12 to 14 litres per minute in pretty good conditions. The weather, which equates to probably 700 to 800 litres per hour. So it's a good little system. Plenty of water for the house facility, which is all we've really got it plugged into, and any excess goes then into the stock side of it. But the weather, like water temperature, whether it's hot, cold, for some reason seems to affect the system a little bit, so it can drop back down and won't perform as well in cold conditions. And that's pumped into at the moment, that system is only doing the homestead facility, which consists of sort of 4 houses, shearers' quarters, some lawns, some gardens, feeds the dogs, all those sort of things. And any excess, if I've got the excess power or the time to do, I'll push that into the shandy up the salty water in the holding paddocks here. I haven't quite got it set up good enough yet. It's a bit of a staging process of getting to that. But what it has done from a cost effectiveness point for us is if you want to look at, this is quite a historical old place with a lot of, we've got a rubbish dump up the back here, and there would be perhaps 20 or 30 old washing machines, another 10 or 15 hot water services, all the pipes around the place, we're continually replacing all of them. So all of those sort of things alone, it's a big savings with good quality water running through all of those systems now, extending the lifespan of all of those items that we're not having to replace quite often. We've now got a vegetable patch which grows, as good as anywhere if I remember to water it. So all of those things is pretty much what it does just in a minute. As soon as I get my power system a little bit better, I'll hope to introduce another big storage tank to be able to then, in those peak times, try and lessen the pressure on the stock in regards to the quality of water when they come in under stress. So that's pretty much the guts of the system and how it works. Probably the future stuff I might just touch on. So this whole system you're looking at here now, I think I'm hoping to do over the next couple of years for perhaps try. We've got a couple of bores further to the north that are at 9,000 parts or even 10 or 11,000 parts. This should be able to, the whole thing you're looking at should be able to run it from a solar system outright. I believe it'll take probably 8 to 10 panels to do that, so it'll be a bit of a system and a bit of a control box to go with. But when we get to that stage, it'll open up a considerable amount of more country for me to be able to run some stock on where we can't, probably because of the salty water at the moment. But that's all future sort of stuff. And I think that's about it, Jodie. I think I'm at the end of my little talk.
Thanks, Peter. We've got a few questions come in to Pip. I'll hand over to her to ask them.
Thanks, Jodie. Thanks, Peter. That's fascinating. Goodness me, that's a lot of time, effort and money that's gone into it there, which I'll lead into a question in regards to finance. How do you find the running costs of the plant? And you did touch on earlier about the fact that as producers, we all have that lovely trait of being quite frugal. So do you find that it's worthwhile going down that track?
Yes, I think it is, Pip. I think it's the motor you're looking at there is a little bit bigger than, it starts at 1.1 kilowatt is the motor that's actually on the machine there now, and it's a 0.5 kilowatt one that drives the whole system. At the minute, it's only doing 3 or 4 hours a day to just supply this time of the year. Just the house is only me and a couple of people here sort of thing, so it's not doing a lot. It's not a power constraint there at the minute, but if it's going all the time, I think the technology is moving so quick. Yeah, I guess like all things lead on to another thing, which means that I've got to get my solar batteries and the solar system and all those sort of things probably upgraded further down the track where we're not running off a generator at all, which is certainly the plan. But it's not a big drawer of power, this system, compared to most desal setups. It's a bit of cost involved. The membranes inside those silver cylinders are $480 each, so there's a bit of money there, but they've assured me that they should last 10 years if you don't block them up. Now, I've blocked one set up with sand and iron when I was learning in the first 6 months, so I've done a little bit of dough in on that, but look, if it's done right, that shouldn't have happened. And then you've only got the filters on that little blue canister, which are about $35 to $40 a pop, I think they are. So they're not a massive cost, and you go through one of them every sort of 6 weeks. So that answer the question, Pip?
Yeah, that's great, Peter. And so in that regard, there shouldn't be considerable pump wear, even with the bore water potential damage?
No, he's insured me. It's all galvanised. All the cylinders are galvanised. There's no, it's early days. I'm only 2 years into this, and I've had some teething issues getting to it at this point in time, but he's quite confident I'll get 10 years out of the unit you're looking at there now without any major dramas. Now, I think that will depend on that Grundfos pump. If I was to go 24/7 with it, like as in every day it won't last. But at the moment, it's doing 4 or 5 hours a day. It's going to last a long time. So, yeah, there'll be a few constraints, but that should be very low cost once you get rolling with it.
Thanks, Peter. And in regards to piping, do you have to take into consideration sort of elbow joints and that type of thing is in placements and in regards to efficiency? Does that make any difference?
Not that I'm aware of. Like the anti-scale little thing that I've put in there now should stop those. You'll see this system in particular has got no elbows. It's all curved. So if you look at those pipes on the ends, are all curved sort of pipes. So that's supposed to help with the flows going through. The anti-scale should stop any of that stuff corroding up on the inside or blocking up in any manner. And I can only speak to it certainly hasn't been an issue in the 2 years in that area.
We'll finish up with this one, which is, have you got any recommendations or hints for producers considering desal, Peter?
Well, I guess it's like most things in life. I guess you have a crack and see how you go. I've had some teething issues, and each setup will be the water quality wherever you are or whatever it is. But it's certainly at the moment with livestock being worth it what it is, and Emma sort of touched on a little bit of that sort of stuff. That water quality is pretty important. So certainly, although I haven't quite got that to what the initial aim was for what I was looking to do, it depends on every producer on what they're looking to do going forward. I've started off on a smaller system here to try and get my head around it, which I think I have sort of now. So the next stage will be, so I guess if I was going to give anybody any, it would be just have a crack and try and work work your way through it from there, and don't get too frustrated with it, because there has been a few little frustrating minutes, but I'd never go back. There's not a hope in I'll stick with this, because once if you don't know any different, it's fine, but as soon as you're showering under good fresh water instead of salty stuff like you're coming out of the sea all the time, I'm not going back to that, I can assure you.
No, well, I don't blame you. Well, no, that's great. Thanks, Peter. Again, we need to thank all of our presenters. So Cameron, Peter and Emma, thanks so much for your time. So on behalf of Primary Industries and Regions SA, AWI, SA Sheep Industry Fund, SA Arid Lands NRM Board and SA Murray-Darling Basin NRM Board, we thank you all for joining us tonight and enjoy the rest of your evening. Thank you.